Hello everybody. Today, we are going to discuss about gravity dams. This is the first part of gravity dam. This video includes basic ideas about gravity dam, different terms related to gravity dam, factors affecting site selection, advantages and disadvantages of gravity dam. Here we are also discussing about the forces acting on a gravity dam. This presentation is prepared by Anis K. Assistant Professor, Department of Civil Engineering, MEA, Engineering, College, Perinthalmanna. A gravity dam is a solid structure, made of concrete or masonry, constructed across a river to create a reservoir on its upstream. The section of the gravity dam is approximately triangular in shape, with its apex at its top and maximum width at bottom. The section is so proportioned that it resists the various forces acting on it by its own weight. Gravity dams are usually consist of two sections, namely, the non-overflow section and the overflow section or spillway section. From the diagram shown here, we can see different parts of a typical gravity dam. Axis of the dam is the line of the upstream edge of the top of the dam. The axis of the dam in plan is also called the baseline of the dam. The axis of the dam in plan is usually straight. Length of the dam is the distance from one abutment to the other, measured along the axis of the dam at the level of the top of the dam. Structural height of the dam is the difference in elevations of the top of the dam and the lowest point in the excavated foundation. However, it does not include the depth of special geological features of foundations such as narrow fault zones below the foundation. In general, the height of the dam means its structural height. Toe and heel. The toe of the dam is the downstream edge of the base, and the heel is the upstream edge of the base. Maximum base width of the dam is the maximum horizontal distance between the heel and the toe of the maximum section of the dam in the middle of the valley. Hydraulic height of the dam is equal to the difference in elevations of the highest controlled water surface on the upstream of the dam and the lowest point in the riverbed. Spillway, a structure over or through which flood flows are discharged. Gallery, a passageway within the body of a dam or abutment for the inspection and drainage purposes. Crest, the top of the dam. These may in some cases be used for providing a roadway or walkway over the dam. Sluiceway, opening in the dam near the base, provided to clear the silt accumulation in the reservoir. Next, we have to discuss about the factors affecting site selection of dams. Topographically, most suitable place must be chosen for construction. Ideally, it must be a narrow gorge, or a small valley with enough catchment area available behind, so that calculated amount of water can be easily stored in the reservoir created upstream. All dams should have an adequate spillway for passing flood flows. If a river gorge is narrow, then there may not be sufficient spillway width available, and a suitable location, on the periphery of the reservoir, has to be found to locate a spillway. The way through which river can be diverted at a particular site. For making way for construction of the dam may affect the design of the dam and also the construction schedule. The average quantity of sediment carried by the river has to be known as precisely as possible, which would give an idea of the rate at which a proposed reservoir may get filled up. Site selection should be done in such a way that it must cause minimum damage to public in the event of destruction or failure. Technically, the site must be sound as possible, that is, strong, impermeable and stable. Strong rocks make the job of designer easy. Impermeable sites ensure better storage inventories. Site must be stable with respect to seismic shock slope failures around dam. The site should not be far from the locations where materials which will be used for the construction are available. Their non-availability will make the cost of project high. The creation of the dam must not create ecological disorder. Fish culture is the first sector that suffers the major shock due to dam construction. It indirectly affects the other population. The dam should become an acceptable element of the ecological setup of the area. Now we are going to discuss about the advantages of gravity dams. The advantages are: gravity dam is strong, stable, and durable. Suitable for moderately wide valleys having steep slopes. Can be constructed to very great heights. Suitable for an overflow spillway section. Maintenance cost is very low. Does not fail suddenly. Disadvantages of gravity dams are: gravity dams of great height can be constructed only on good rock foundations. Initial cost is more than earth dam. Takes longer time in construction. Require more skilled labor than earth dam. Subsequent raise is not possible in a gravity dam. Now we are going to discuss about various forces acting on a gravity dam. They are: water pressure, weight of dam, uplift pressure, pressure due to earthquake, ice pressure, wave pressure, silt pressure, wind pressure. Diagram shown here shows different types of forces acting on the gravity dam. Water pressure on the upstream face is the main destabilizing force acting on a gravity dam. Tailwater pressure in D/S side helps in stability of the dam. The water pressure always acts normal to the face of dam. It is convenient to determine the components of the forces in horizontal and vertical directions instead of the total forces on the inclined surface directly. The water pressure intensity varies linearly with the depth of water measured below the free surface. Upstream face may be either vertical or inclined, and downstream face will be always inclined. When the upstream face of the dam is vertical, the water pressure diagram is triangular in shape. The total water pressure per unit length is horizontal and it acts at a height h/3 above the base of dam. Figure shows the distribution of pressure due to water. Next force is weight of dam. The self-weight of the gravity dam is the main stabilizing force which counterbalances all the external forces acting on it. For construction of gravity dams, the specific weight of concrete and stone masonry should not be less than 2,400 kg per m³ and 2,300 kg per m³ respectively. The self-weight of the gravity dam acts through the center of gravity of the dam. It is calculated by the following formula given here. The water stored on the upstream side of the dam has a tendency to seep through the soil below foundation. While seeping, the water exerts an uplift force on the base of the dam, depending upon the head of water. Portion of the weight of the dam will be supported on the upward pressure of water. Hence net foundation reaction due to vertical force will reduce. To reduce the uplift pressure, drainage galleries are provided on the base of the dams. Dams are subjected to vibration during earthquakes. Vibration affects both the body of the dam as well as the water in the reservoir behind the dam. The most danger effect occurs when the vibration is perpendicular to the face of the dam. Body forces acts horizontally at the center, and water vibration produces a force on the dam acting horizontally. IS 1893/1984 code specifies design criteria under earthquake condition. Next one is ice pressure. Ice expands and contracts with changes in temperature. In a reservoir completely frozen over, a drop in the air temperature or in the level of the reservoir water may cause the opening up of cracks, which subsequently fill with water and get freezed. When the next rise in temperature occurs, the ice expands and, if restrained, it exerts pressure on the dam. Good analytical procedures exist for computing ice pressures, but the accuracy of results is dependent upon certain physical data which have not been adequately determined. Ice pressure may be provided for at the rate of 250 kPa, applied to the face of dam over the anticipated area of contact of ice with the face of dam. When very high wind flows over the water surface of the reservoir, waves are formed which exert pressure on the upstream part of the dam. The magnitude of waves depend upon the velocity of wind, depth of reservoir, area of water surface. Calculation of wave pressure according to Indian standards are explained here. Here we can see the distribution of wave pressure and the location of wave pressure acting on the body of the dam. The pressure distribution is curvilinear. However, for design purpose, the pressure distribution may be assumed to be represented by a triangle as shown in the diagram. Next one is silt pressure. The river brings silt and debris along with it. The silt load gets deposited to an appreciable extent when dam is constructed. The dam is therefore subjected to silt pressure in addition to the water pressure. SID pressure is calculated according to the formula given here. Wind pressure. The top exposed portion on the dam is small and hence the wind pressure on this portion of dam is negligible. But still an allowance should be made for the wind pressure at the rate of about 150 kg per m square. For the exposed surface area of the upstream and downstream faces. Thank you for watching the first part of gravity dams. Now go to the second part of gravity dam for the following topics. Stability analysis and modes of failure. Types of load and load combinations for design. Safety against overturning, sliding, and overstressing. Elementary profile and practical profile of gravity dam. Limiting height of gravity dam. Various components of gravity dam. Grouting. Instrumentation in dam.